All right, this is from Math Links 8, Chapter 6 on fractions. This is your practice test of questions. So question number 1 in the review says, which expression does not equal 4 times 1/3? So really the first thing we need to do is just look at the 4 expressions and say to ourselves, okay, which one is clearly equal to it? And the first one you said is probably equal to it was this. And I asked people, why would that be? And because of the commutative property, the order in which you multiply two numbers, or is that the associative property? I can never remember. But the order in which you multiply two numbers together does not affect its product, so therefore C is definitely equal to it. And if I actually think about what is the product of this, well, 4 can be considered to be 4 over 1 multiplied by 1/3. Or if you had a third and you multiply by 4, how many thirds would you have? Your answer is 4/3. So clearly, this is also equivalent to that. And if I change 4/3, which is an improper fraction, to mixed, I would have this answer. So based on the fact that I know A, B, and C are all equivalent to 4/3, it has to be D. And the answer why it is because if I multiply all my numerators, I get 1. And 3 times 3 times 3 times 3 is actually 81. So therefore 1 over 81 does not equal 4/3 or 1 and 1/3. Question 2 says which expression equals, this time we're not looking for not equals, but rather equals 4/5 divided by 2/3. Now remember, there are two methods you could solve this question with. The first method for division of two fractions is you can find a common denominator, which we would use 15. And you have 12/15 divided by 10/15. And when you divide the numerators and divide the denominators, you end up with 12 divided by 10 over 1, which is simply 12 divided by 10, which is simply 12 over 10, which is 1 and 2/10. Oh my heavens to Betsy, this is going forever. Which is 1 and 1/5. How laborious was that? Now we realized very quickly as we were practicing both methods back in the chapter that we did division, that that was a very inefficient method for dividing two fractions. And we said, you know what, there's a much easier method. And that easier method was to keep the first fraction and multiply by the reciprocal of the second. And simply multiply your numerators to get 12 and multiply your denominators to get 10. And you get 1 and 2/10, which is 1 and 1/5. Same answer, but a much more efficient way of getting that answer. And therefore, I did all that work for nothing. But this expression is the multiplication of the reciprocal, and therefore, C is your answer. Question 3, which expression equals the reciprocal of 2/3? So the reciprocal of 2/3 is 3 over 2. So really what we're looking for is which of these expressions equals 3 over 2. Well, if I think of this one, 1 minus 2/3, I know that this is more than 1. This is 1.5, really, isn't it? So 2/3 is really 1.5. And I know that A, 1 take away something, is not going to leave me an answer that's greater than 1, which 3 over 2 is. So I can eliminate A right off the bat because 1 take away any fraction is going to be a value less than 1. And 1.5 is greater than 1, so it's not that for sure. This one here, when you multiply a number by 1, or 1 times anything, you'll always end up with itself. So 2/3 times 1 or 1 times 2/3 is going to be 2/3. So right off the bat, just by using logic and not by using any kind of algorithm here, I can eliminate it down to a 50-50 chance. Now I know that 1 plus 2/3 is equal to 1 and 2/3. That's a pretty easy answer. And since 3 over 2 is 1.5, I can eliminate C. Ergo, therefore, it must be B, which is my answer. And of course, if I take that first answer, 1, and multiply by the reciprocal, I end up with 3 over 2, which is correct. So the answer is B. Question 4, we have a BEDMAS question. And actually, it's a multiple choice. And these are pretty good to do because it requires you to still solve it. But from a teaching standpoint, it's much easier for me to correct A, B, C, or D than it is to correct the answer. So if I gave you this on a test, it's easy for me to do, but not so much for you. So the first thing I'm going to do is I'm going to solve by brackets. And when you're subtracting, you're going to find a common denominator. You're going to use equivalent fractions. And 1/6 take 8/6 take away 1/6 is 7/6. So I'm just going to leave it like that. So when I simplify that brackets, I keep it right where it is, and the rest stays where it is as well. When I multiply these together, I get 7/12 plus 3/4. And finally, I have addition, which requires a common denominator as well. So 7/12 plus how many twelfths? That'll be 9/12 equals 16/12, which is 1 and 4/12, which is equal to, in lowest terms, 1 and a third. And your answer is C. Seems like there's a lot of C's for answers here, isn't there? If you had just went all C, I think you would have done okay. Yeah. Or if there's all of the above, choose that. Question 5 says the quotient, and some people got hung up on what does that word quotient mean? Well, to date, you've learned the sum is the answer to an addition. Difference is the answer to subtraction. Product is the answer to multiplication, and quotient is the answer to division. So it's the answer to a division. The quotient for 3/4 divided by 5/12 expressed in lowest terms. And since we just talked about this, the easiest way to solve this is to multiply by the reciprocal. Check for cross reduction because you're multiplying now. Some people think you could cross reduce division. Some people did this. What would you tell those people? You can't do it. Why? Because you can't cross reduce division. You can only cross reduce multiplication. And until you turn it to multiplication, you can't cross reduce. But now you can. 12 over 4, if I thought about 12 over 4, that would reduce down to 3 over 1. So I'm going to reduce this to 3 over 1. Now that I had that 3 over 5 can't cross reduce, so 3 times 3 over 1 times 5 will become 9 over 5, which is equal to 1 and 4/5. So our answer is 1 and 4/5, which we also see in as an improper fraction. So our answer is A, 9/5. Question 6 was a question that freaked out a lot of students. It says the product of a fraction and its reciprocal is a purple box. Well, what does this purple box mean? Well, if I take any fraction, and I'm just going to choose the wonderful fraction 2/3, and product means multiplication. So if I multiply it by its reciprocal, what answer do I get? I get 6 over 6, which is equivalent to 1. And this works with any fraction. So if I take 1 and 2/3 and multiply it by its reciprocal, by the way, what is the reciprocal of 1 and 2/3? Who said it? Somebody said it. 3/5. And how did you know it was 3/5? Well, because you first had to examine it as an improper fraction and then think of it as its reciprocal. So if I multiply these two together, of course, 1 and 2/3 is really 5/3. I get 15 over 15, which is equal to 1 again. So the answer is the product of a fraction and its reciprocal will always be 1. Okay, will always be the number 1. Question 7, the value of this quotient or the solution to this is going to be what? So again, here, the easiest way to do it is to change them to improper. So we're going to have 8/3 divided by 14/3. Now the easiest thing about this is the first time that we've ever divided that it's not necessary to multiply by the reciprocal. Because if you understand the common denominator method, looking at this question, what's your answer? 8/14. You see it? Because your denominators could become 1, and your numerator is going to be 8 divided by 14, which is 8 over 14. But most of you probably didn't. You probably just kept the first fraction and multiplied by the reciprocal, which is okay, because when you cross reduce, what are you going to end up with? Still 8 over 14, which is lowest terms. Is that right? Oh, it's not lowest terms because both are divisible by 2, giving you 4/7 in lowest terms. Question 8 says the value of the product. What am I going to do here? Well, I mean, the hardest way to solve this question would actually be to use the area model. You know, 2 1/4 and 1 1/3. This would be 2, this would be 1/4, this would be 2/3, and this would be 1/12, and then add those parts together. You could actually multiply those two fractions together by using what we learned previously was your area model, right? But obviously that's not the most efficient method. The easiest method to solve it would be to simply change these to improper fractions, attempt cross reduction, and get your final solution of 3. Now, if you didn't cross-reduce and you're still one of those people that doesn't believe me that that's the easiest thing to do, then you ended up with this and you're like, no problem. I'm going to do this question without cross-reduction. 36 over 12, which equals 3. All right, you'd still get the same answer if it didn't cross-reduce, but how many 12s and 36? There's exactly 3 with no fraction left over. Question 9, straight up evaluate. Multiplying fractions requires cross-reduction if possible. Wonderfully works right here, giving you 5/16. If you didn't cross-reduce, you got 15/48. And the problem with 15/48 is it's not in lowest terms, because both top and bottom are divisible by 3, because I know my divisibility rules, right? 1 plus 5 is 6, which is a multiple of 3. 4 plus 8 is 12, which is a multiple of 3. So both 15 and 48 are divisible by 3, which would reduce the lowest terms of 5/16 anyway. Okay? Be aware of your divisibility rules, especially with 3, because they kind of sneak up sometimes. The easiest way is to multiply by the reciprocal of 7/10, which is 10 over 7. If you cross-reduce, 10 over 5 will reduce to 2 over 1. You get 12 over 7, which is 1 and 5/7. If you didn't cross-reduce, you got 60 over 35, which is 1, and 25/35, which is 1 and 5/7 when you divide both numerator and denominator by 5. The next 3 parts, C, D, and E of that same question, are the multiplication of a mixed fraction and a proper fraction. Again, you could technically use 3 and 3/5 here and 3/8 here. Multiply 3 and 3/8 to get the answer to this. Multiply 3/5 and 3/8 here. Add them together. You get your product, but a much more efficient way is to convert your mixed fraction to improper and multiply it like this. Can you cross-reduce? Yes, you can. If I consider 18 over 8, what would 18 over 8 have been in lowest terms? What's divisible into both 18 and 8? 2 for sure. 9 over 4, is that lowest terms? Yeah. So this 18 over 8 can reduce down to 9 over 4, right? And then when I multiply it out, I get 27 over 20, which is 1 and 7/20. If you didn't cross-reduce, shame on you. But if you didn't, you got 54 over 40, which is 1 and 14/40, which is 1 and 7/20. Right? You still got the same answer without cross-reducing. You just had to reduce your final answer. Your next question, division by a mixed fraction. So the first thing I'm going to do is just change it to division by an improper fraction. And once I see that, if I said, what's the reciprocal on your test? I said, what's the reciprocal of 2.5? What would you say? The reciprocal of 2.5 is 2/5. But you can't examine the reciprocal of a mixed fraction. You can tell me the reciprocal of an improper fraction. Cross reduce, 2 over 10 would reduce to 1 over 5, which gives me 9 over 25 as a final answer. If you got 16 over 50, you just didn't reduce it. Sorry, 18 over 50. Next question is a bedmass question with more than one operation. We have brackets, we have division, and we have subtraction, 3 different things going on. First thing we're going to solve is the addition. And before I get carried away with common denominators, improper fractions, let's just pause, take a deep breath, and look what questions in those brackets. Do I really need to change that to an improper fraction? Do I really need to rewrite that? Or can I do 1 1/4 plus 3/4 in my head? 1 1/4 plus 3/4, all of y'all should be able to do to get 2, right? If you look at 1 1/4 pizzas plus 3/4 more, it's 2. So a smart person, a person who is observant, will be able to do those brackets without wasting their time changing it to improper and doing all that kind of junk. Just put 2. And now that you have that, I'm going to put 2 over 1 multiplied by the reciprocal of 1 1/2. How do I get the reciprocal? Have to examine it as improper. So what's the reciprocal of 1 1/2? 2/3. So there. Actually, what am I going to probably do with this? Change it to improper. So now all I did is I changed my whole number 2 to 2 over 1. I changed my division and multiplication, changed 1.5 to its reciprocal, and changed 1 1/3 to an improper fraction. I haven't done anything yet. I've just converted everything to manageable numbers. This is going to be 4/3. Take away 4/3, which is a beautiful number. It is the number 0. 4/3 take away 4/3 is 0, and that's your answer to E. Question 10 says, Leisha worked 6.5 hours for $14 an hour. How much did she earn? If you're having difficulty with it, one of the strategies we've been talking about is think of an easier question. She worked 6 hours for $10 an hour. How much? $10 per hour. How much did she make? She would have made $60. So taking this and multiplying it by this is our solution. So therefore, and it doesn't matter if you did 14 times 6.5 or 6.5 times 14. We're going to do 6.5 hours multiplied by the $14 per hour. The interesting thing is you could do 6 times 14 and a half times 14, and that's not a bad way to do it, right? So if we think about this, and I'm just going to give you two strategies here. 6.5 multiplied by 14. 6 times 14 is $84. So if she made $6 an hour, she would have made 84. Half an hour at $14, half of 14 is 7. So if I combine those using my area model, 6.5 times 14 is $91, which is probably a pretty efficient way to get the answer. But another way is to multiply 6.5 in its improper form by the whole number 14 expressed as 14 over 1. Cross reduce, and you still get 7 times 13, which is 91. Therefore, she earned, E-A-R-N-E, earned $91 for 6.5 hours. Question 11. So Chad likes to eat granola for breakfast every day. He eats 3/4 of a box per week. What fraction of a box of granola does he eat per day? What are our two strategies for story problems? Think of an easier question, or let's try drawing this. So this is his box of cereal. And he eats how much? 3/4. So in 1 week, he eats 3/4 of a box of cereal. How much does he eat per day? Well, how many days are there in a week? 7. So I'm going to cut this into 7 days. 1, 2, 3, 4, 5, 6 lines make 7 parts. Right? This is Mondays, Tuesdays, Wednesdays, Thursdays, Fridays, Saturdays, and Sundays parts that he eats. In 1 day, what fraction of a box did he eat? Well, the box was divided into 4 parts. Now what's it divided into? 28 parts. And how many parts of that box does he eat on Monday? 3/28. So our solution from drawing it is he eats 3/28 of a box per day. What operation did I really use here? I really used 3/4 of a box divided by 7 days, right? In which case I'm going to do 3/4 multiplied by the reciprocal of 7. And Wiley, what's the reciprocal of 7? Excellent. In which case I'm still going to get 3 over 28. How many boxes of granola does he eat per year? So if he eats, you can do it one of two ways. You can take your 3/28 of a box, which is 1 day, and you can multiply it by 365. Or, alternatively, you can take 3/4 of a box and multiply it by what number? 52. Because there's 52 weeks in the year. Either way you do that, you're going to get the same answer, right? As Levi Driscoll has just said, if I take 52 weeks in a year and multiply it by 7 days, I only get 364. What happens? The leap year, February sometimes has 28 days and sometimes it has 29. Yeah. Weeks, not months. There's not 4 weeks in every month either, is there? No. Some of them have 4.5 weeks. 4 weeks is 28 days. Anyway, I digress. Question 12 says, in computer terminology, a bit is 1/8 of a byte. So a strategy I'm going to use here is I'm going to draw a byte. Okay, this is a byte. How many bits make up a byte? A bit is 1/8 of a byte. So if I cut these into quarters and then each of these into, this is a bit, which is 1/8 of a byte. How many bits equal a byte? 16 bytes. So how many bits equal 1 byte? 8. How about 2 bytes? So I know that if I take 16 and multiply it by 8, I'm going to get my answer. But the correct solution is if I take my 16 bytes and divide them into sizes of 1/8 in size each. That is a tricky question because 16 bytes divided into groups of eighths. How many eighths are there in 16? How many eighths are there in 16? Well, how many eighths are there in 1? How many eighths in 1? 8. How many eighths in 2? So when we think about that, what we're really going to do here is we're going to take our 16 and multiply by the reciprocal of 1/8. So that's going to become 16 times 8, which is 80, and 48, which is 128. So therefore, there are 128 bits in 16 bytes. Question 13 says printer paper is sold in packages of 500 sheets. Does anyone know, just out of a piece of trivia here, what they call a pack of paper, a 500 sheet pack? It's called a ream. R-E-A-M is correct. R-E-A-M. A ream of paper. Go to the, yes. So if a printing job uses 1 3/4 packages of paper, how many sheets does that? So one package is 500. So if I multiply that by 1, I would have 1 package of paper. 1 and 3/4 would be multiplying it like that. 500 sheets multiplied by 7/4. Crossing reducing here is a little tricky, but if I divide 500 by 4, I get 125 over 1. If you didn't cross reduce here, that's no problem. But when you multiply that out, you get 700. You get, did I make a mistake somewhere? Oh, 875 over 1, and therefore 875. So in 1 3/4 reams, 1 3/4 reams of paper equals 875 sheets. There you go. Worst writing ever. Question 14 says Leanne is about to buy a DVD player that costs 2.5 times her weekly allowance. If she spends 3/4 of her allowance on other things every week, how long will it take her to save enough money for the DVD player? This is a really tricky question because there's actually a second part to it. So if we think about this rectangle as being her allowance, then the yellow part, and I'll highlight it in yellow, is 3/4 of her allowance. And what does she do with this yellow part? She spends it on stuff. What about this green part? She saves. So how much of her weekly allowance does she actually save? 1/4. So the thing is, how much allowances, how many allowances, or how many of these rectangles, these total rectangles, does she need to save enough money for a DVD player? She needs 2.5 times her entire allowance to save up for the DVD player. So 2.5 allowances divided into the 1/4 that she's actually going to save, divided into quarters. How many quarters are there in the 2.5 allowances that she needs? So if I think of it that way, in the 2.5 allowances divided into just quarter allowances that I have, how many of these are going to be in the 2.5? Well, 5 halves multiplied by the reciprocal is 20 over 2, which is 10. Therefore, it is going to take her 10 weeks to save up enough money for the DVD player. And I'm going to show you a different way. Here is her allowance, empty. Now, how much does she need to save up for the DVD player of those empty boxes? She needs 2 full of them, 2 full ones. She needs all of this one, And all of this one, and how much of this one? Half of those two right there. She needs 2.5 allowances. If she's only saving this much per week, right? Oh, it's not going to work. If she's, let's see if I can get it in there. I can't, can I? All right, get rid of So obviously, 1 week, 2 weeks, 3 weeks, 4 weeks to save up an entire allowance, 8 weeks to save up 2 allowances, 9 weeks, 10 weeks to save up her 2.5 times of her allowance. Question 15, I'm going to skip because I don't like the question. I shouldn't have given it to you, so we're not going to do 15. It will not appear in its variations of the test. It's kind of a silly question. I don't like it. So that's all we're going to do today.